Hi guys, good evening everyone. Welcome to the session and welcome back to the India's most comprehensive preparation platform, that is the BYJU'S Exam Prep, and welcome to the Formula 1 revision session once again. Yes guys, this is the Formula 1 revision of signals and systems. This is the Formula 1 revision of signal and system, and the part number 2 of it day before yesterday. Yes, that is on the Wednesday. We already had the part number 1 of this Formula 1, and today we are going to discuss we'll continue the formulas of signal and system. Some of the formulas we have seen in the part 1. Today we'll continue. Let's get started. Very good evening all. Okay. Yes, so in case somebody new to my session, this is a brief intro about me. This is your mentor Rakesh. I have secured All India rank 9th in the GATE examination and completed my masters from Indian Institute of Science, Bangalore. Right, and these are my major area of expertise which I have been dealing for more than 12 years now. Right. Good evening Dreamer, good evening Chandrasekhar. Yes Dreamer, it is better. Okay, chalo. Let's move ahead. Yes guys, so yes, 5th November, that is tomorrow, Saturday, a free mega workshop to be conducted on BYJU'S Exam Prep app. So guys, if you are one of the GATE 24 aspirant, or if you are planning to appear for GATE 24 as well, just a second, what happened suddenly? Yeah, this looks good. Okay. Right, or if your juniors, your colleagues, anybody planning to appear for the GATE 24, yes, here I bring you a detailed 1-year preparation strategy for the GATE 2024. Join me live Saturday 8 p.m. Also guys, one more quick and important update for you. This Sunday, that is 6th of November, day after tomorrow. So now guys, we have had several aptitude sessions on the Sunday, targeting some topics, targeting some practice areas, but this Sunday I thought, it's already the cricket festival going on, it's a T20 festival going on, so this Sunday let's have a T20 blaster of general aptitude in the form of live quiz. Yes, this Sunday a live quiz, a live Menti quiz of general aptitude on the same BYJU'S Exam Prep YouTube English channel, the same channel where you are watching this session. The same channel where you are watching this session, we'll have this live, and the timing is 11 a.m. Yes, mark the time as well, and it's going to be a live quiz. It's going to be a live quiz. So, test yourself in the general aptitude preparation. We have been dealing with several topics, and we'll now take up a quiz format. Okay, with rapid fire question and answer, and you will be given the solutions as well, of course. Okay, so this Sunday 11 a.m. live, and guys, let's move ahead and let us get started with the first thing, and let us pick up. Let us choose to start from the continuation. Yes, signal and system formula revision part number 2, and here I start up with the Laplace transform. Let us first start with the formula revision relevant to the Laplace transforms. Okay, so if there is a signal xt, the basic Laplace transform formula, all important Laplace transform pair with their ROC, important Laplace transform properties, all those things will be covered, so that this again becomes like a formula book whenever you need to appear in any test. See, you have studied signal once, your concepts must be clear. Now if you want to appear in any of the test related to signal and system, is it buffering? Just let me check. Just allow me a moment. Yes guys, it's all fine, I think, correct? Okay, so whenever you are going to, in future have a quick test of signal and system, whether, you are going for mock test or signal system subject-wise test, but you need to review up, this is going to help you as a formula book, provided you have studied all the concepts in the, very first attempt. First is concept, and then once you have thorough concepts, then you can use this formula booklets. Otherwise, the GATE is not a formula based exam, but after studying the concept, somehow we need the formula at one place. This is what the series is doing for you. This is what the series is going to help you out in that particular manner, right? Chalo guys, okay, let's get going on. Okay, so the Laplace transform, as we know, of a signal xt is defined as integral xt e raised to the power minus st dt, where we represent this as a Laplace transform pair xt having the Laplace transform xs. We represent this by the double-sided arrow. X is having the Laplace transform xs, and xs is having the inverse Laplace transform of the xt, right? Now for example, just one example let us take to just a second, to continue with our discussions in the continued manner. Just a moment, I think this is responding little slow. Okay, so if I take one of the very basic example and make you understand this whole procedure, suppose xt is e raised to the power minus at ut, and we will come to the Laplace transform pair also. See, mostly we are not going to intend in any solving or any derivation. We will talk mostly in terms of question practice, in the formula and important properties and important results, conclusions. But if I just take up this example, integral e power minus at ut, this becomes integral minus infinity to infinity e power minus at ut multiplied by e raised to the power minus st dt, right? Because of the ut, the limit becomes 0 to infinity, and you have e power minus of a plus st dt, and this is going to be solved as e power minus of a plus st divided by minus of a plus s. Now you can get the formula easily, limit is 0 up to infinity. Okay, but the whole point is when you solve this, you write this upper limit e power minus infinity, lower limit is e power minus 0 divided by minus of s plus a, e power minus infinity 0 and e power 0 is 1, so that you get minus 1 upon minus s plus a, and 1 upon s plus a is your answer. That is what you actually write down. 1 upon s plus a. But how it is guaranteed that this is going to be e power minus infinity? It may diverge also if it is e power plus infinity. And how it is e power plus infinity, right? If this is positive, right? If this is positive, so you have to make sure, now you cannot compare complex numbers, you can only compare real parts. So you have to make sure that the real part of the s plus added with the variable a, this should be positive, because if this gives you a negative number, minus will be plus, and then you have e power plus infinity, that will diverge. So what is the condition for the answer to exist? What is the condition then for the answer to exist? The condition is that if there is the signal e power minus at ut, it will have the Laplace transform given by 1 upon s plus a. It will have the Laplace transform given by 1 upon s plus a, provided it is given by the Laplace transform 1 upon s plus a, provided the real part of s. Now what is the real part of s? We call it as c. S is written as sigma plus j omega, right? And the real part of s, which is known as sigma, added with a should be positive. That means sigma should be greater than the minus a. This is the inequality you get. Sigma should be greater than the minus a. Okay, sigma should be greater than minus a. So sigma is like real part of the complex variable. Real part of a complex variable, you can also call it as the x, because we draw the real part on the x-axis, right? So whenever you take x equal to constant is a line parallel to the y-axis. X equal to constant is a line parallel to y-axis. Now you want sigma greater than minus a. So similarly, if I take sigma equal to minus a, it's going to be a line which is parallel to the y-axis. So sigma greater than minus a will be a region which is ahead of this line, right of this line. Sigma should be sigma equal to minus a on the line, but for sigma to be greater than minus a, I need to take the values which are on the right hand side. So this is what is the picture coming up here? This is making an entire region in the s-plane. This is making an entire region in the s-plane for which Laplace transform of the signal will exist. Otherwise the signal will not exist. And that is why, guys, always with the Laplace transform you have a concept of ROC. Always with the Laplace transform you have the concept of the ROC, region of convergence. always with the Laplace transform you have the concept of the region of convergence. Yes, right. So that is what this is, the region in the S-plane for which the Laplace transform will converge. Similarly for e power minus at ut, it will be sigma less than minus a. I will write down all formulas together. Okay, so always what is important with the Laplace transform is the ROC. Okay, it is the ROC. So let's do one thing. Let us first talk about the important Laplace transform pairs. Let us first talk about the important Laplace transform pairs along with the ROC important pointers. So what are some important points about ROC? Okay, so like I have shown you right now that ROC, what was the type of ROC now discussed? It was a region in the S-plane, okay, which is parallel to the y-axis. Okay, there will always be regions which will be drawn parallel to y-axis. You will never get ROC like this. You will never get a ROC like this. So there will be regions or there will be strips in the S-plane which is parallel to the y-axis. Y-axis here means imaginary axis. Imaginary axis bole to j omega axis. The imaginary part of S is the j omega. Right. ROC cannot contain any poles because pole is the point where Laplace transform is undefined. So ROC cannot contain a pole. Very simple logic it is. If a signal is of finite duration, as I told you, we are not going to calculate the Laplace of each and every signal. We will not derive it for each and every signal. We need to complete our formula booklet. Okay. Like one example I've shown you, but yeah, let's take the result. If a signal is of finite duration and absolutely integrable, ROC is the entire S-plane, something like this, delta t, right? This is a finite duration signal. It's the delta t has negligible duration and its ROC is always the entire S-plane. If the signal is right-sided, these 3 points are very much important. Actually, all 4. Finite duration signal, right-sided signal, left-sided signal, two-sided signal. For a right-sided signal, ROC is also right-sided. Right, ROC is also right-sided, lying to the right of the rightmost pole. So last case, the answer was 1 upon S plus A. Right, if I take 1 upon S plus A, what is the pole of 1 upon S plus A? The pole is S equal to minus A. This is the pole. So where is the ROC? It is the right of the pole. In case if there are multiple poles, so ROC is right of the rightmost pole. Okay, so if a signal is right-sided, ROC is also right-sided, lying to the right of all the poles. That is right of the rightmost pole. Right of the rightmost pole, dear, right? Or if the signal was of finite duration, then the ROC is entire S-plane. Signal is left-sided, so ROC is also left-sided. Where? Left of the leftmost pole. It will be to the left of the leftmost pole, right? If the signal is two-sided, then ROC will be bounded between two poles. It's a finite strip between two poles. Okay, look into this example, e power minus a mod t. For the signal e power minus a mod t, Laplace transform is minus 2a upon s square minus a square. ROC is something like this. Right, s square minus a square. See, what are the poles of s square minus a square? S equal to plus minus a. S is equal to the S is equal to the plus minus A, and ROC will be a region, will be a strip between these two planes. So we say that ROC is a finite strip. It is a strip between two planes. Okay. Okay, between two lines. So if the signal is of two-sided nature, okay, which is neither right-sided nor left-sided, then the ROC has this form. Okay. If the ROC contains the j omega axis, one last very important point, let me just uplift this, right? If the ROC contains the j omega axis, then the Fourier transform of the signal will also exist. So that is the relation, okay, for the Fourier transform to exist. So when does the Fourier transform of a signal will exist? Because, you know, and why this is true? Because when you want to talk about the Fourier transform formula, just you can say that Fourier transform is equal to the Laplace transform evaluated at s equal to j omega. Right, evaluated as the s equal to j omega integral xt e power minus st, s की जगह रखा j omega, तो integral xt e power minus j omega t dt. This is what you know as the Fourier transform formula. So this is equal to the x omega. So Fourier transform is equal to the Laplace transform evaluated at s is equal to j omega. So we know that Laplace transform is defined for ROC, and if the ROC contains the j omega line, j omega axis, which is the pure imaginary axis or the y-axis, then the Fourier transform will also exist. So if the ROC contains the j omega exists, then the Fourier transform of the signal will exist. These are some very guys, when you get good conceptual questions of ROC, these are going to help you. These are some important conclusions about ROC you must remember. Okay, now let us come to the important pairs. Let us come to the important pairs of the Laplace transform. Now again, as I told you with the Fourier transform also in the previous session, that of course questions in the gate will not be like these direct formula. Sometimes 1 mark aa jata hai. Sometimes you can get the 1 marker from these, but mostly the questions will be using this. So there are definitely some important pairs which a student must remember as a formula. Not every time you have to go and find out the Laplace transform of this in the exam. This must be known. Then the question uses these Laplace transform pair along with some properties which I'm going to brief you, and then the good question is made, right? You're comfortable. See, Ravi, again it depends, what type of test, what was the difficulty level of the test. See, if you're comfortable with most of the PSUs, it's a good sign. Only thing is little bit more practice from, workbooks can make you uplift your marks. But again, some of the test series, especially in some of the subject, they design difficult subject tests because, GATE is going to make only one paper. But when you talk about any test series, okay, they have to make several papers, several subject-wise papers, several mock tests. So it happens sometimes some subject tests are difficult. So 50-60% is still different. You can't define only by 50-60%. You have to check what is your performance as compared to others. So you get percentile, you get rank. That analysis if you do, Ravi, then it will be okay. If you're still among 50-60% also, if you're among the top, that is okay. But yeah, if you're in the bottom, then you need to, maybe practice little bit more in that subject from the workbooks or standard books, okay? So moving ahead to the next. Okay, so t e power minus at ut will have the Laplace transform 1 upon s plus a whole square for sigma greater than minus a. Ut, right? Ut, again important one, Laplace transform 1 by s. Tut, Laplace transform 1 by s square. Now I'll tell you, these ROCs, now do you need to remember the ROCs every time? Not required. Not required. See, like e power minus a mod t, I know it's a two-sided signal, right? E power minus a mod t. This is the waveform of e power minus a, sorry, this is not visible. E power a mod t. This is the waveform of e power minus a mod t. This is a two-sided signal lying to the left and to the right. Acha. You know that what you have to remember, these properties is very important. This is like, one of the very important tool of handling the Laplace transform cases. Okay, so isko dhyan rakhna hai. Okay, so now I know that this is a two-sided signal. So ROC has to be bounded between two lines. It should be a strip. Between what two lines? Between the poles. So poles is plus a and minus a. I can draw the ROC. Okay, if I want to talk about this one, see ut, 1 upon s. Ut means only right-sided. So what is the ROC of right-sided? What is the ROC of right-sided? It is also right-sided, lying to the right of the rightmost pole. Sir, what is the pole here? Pole is s equal to 0. Right, the ROC should be right of 0. That's it. Who is asking you to remember that? Who is asking you to remember that? Not required. Not required. Okay. 1 upon s square ramp signal. So this one is step important. This one is the ramp tut. What is the Laplace transform of the ramp? It is 1 upon s square. Again for sigma greater than 0. Okay. T power n. Now generalize. Okay. We had step ramp and generalizing for t power n. It is factorial n upon s power n plus 1. Again the pole is s equal to 0. The ROC sigma greater than 0. Right. Good evening Abhishek. Okay, cos omega t, sinusoidal, cos omega t, sin omega t. The cos omega t has s upon s square plus omega square. Sin omega t has omega upon s square plus omega square. Once again, if you calculate the pole, right? Once again, if you calculate the pole, you get s square equal to minus omega square. What is s? Plus minus j omega. Under root of minus omega square will be plus minus j omega. It is like 0 plus minus j omega. And what I told you in the beginning, the comparison has to be with the real part of the pole. Right? So, what is the pole? Real part of the pole is 0. So, ROC should be compared with 0. Now, the signal is ut. Right? So, ROC should be sigma greater than 0. ROC should be sigma greater than 0. Logically. So, do I need to remember this? Once again, no need to remember. If you are having any doubt in the ROC, please let me know. Because this is what actually, if you, remember the properties of ROC, you don't have to remember them. Okay, chalo. So, these are some important Laplace transform pairs to be remembered. Okay, now as I'm telling you, questions jo aayega na will be on some of these formulas. Sometimes direct 1 marker question on these formula, like sometimes they ask on this one, t power 4 or t power 5 type of questions, right? Otherwise, mostly the questions will be using this and along with some properties of the Laplace transform, they make the question, right? And so let us also move towards the properties. But I'm telling you, this slide is the most important here, most important of the entire Laplace transform discussion. Okay, but let us also brief the properties of the Laplace transform. If two signals are added, linearity, their Laplace transforms are also added. A1 x1s plus A2 x2s. Now, a simple logic. You are having two signals together. Okay, you have placed, you have added or multiplied or convoluted. Whenever you consider two signals together, okay, both of the Laplace transform comes. Matlab you have two Laplace transforms. Just a moment. I have some discomfort with the shoulder. Okay. So, every Laplace transform has its region of convergence. Outside the region, Laplace transform will not exist. Here you have the two Laplace transforms. Here you have the two Laplace transforms. So, what will be the ROC? Think. Here you have the two Laplace transforms. Now, what should be the ROC? अगर आप सोच के देखेंगे तो, what should be the ROC? It should be ROC which satisfies both. मतलब R1 should also be there, R2 should also be there, common of R1 and R2. It has to be intersection of R1 and R2. Okay, so simple logic. Now once again, the remaining ROC, this is just formality. This is just formality, right? Right. Thank you, Rajan. This is just formality. Again, I tell you, if you are clear in this, if you have any doubts here, please let me know. But if you are clear in these properties, then this is nothing for you. Only focus up to here. Only focus up to the Laplace transform, right? Time shifting, just like Fourier transform, will introduce the exponential term e power minus st not xs. Time scaling x at t, 1 upon mod a x of s by a. X of minus t will have the Laplace x of minus n. Some of them very much similar to the Fourier transform already revised. Conjugation, x conjugate t will have the Laplace transform x conjugate x s conjugate. Differentiation, d by dt xt, s into xs. Second derivative, s square xs and etc. Integral minus infinity to the x tau d tau. Integration, Laplace transform will be xs by s. Txt, s differentiation, or this is also known as t times property. Multiplying a signal by t. So txt minus d by ds of the xs. Okay. S shift exponential term in the time with the opposite sign. X of s minus s naught. Here it is e power plus s naught t. E power plus s naught t xt. Right. We'll have the Laplace transform x of s minus s naught. Convolution x1 convolution x2 is x1s into xs. Okay, whenever signals are convoluted in time, the transforms are multiplied. Okay, divide by t, if the signal is divided by t, see again the dual of this, right? If the signal is multiplied by t, it is in differentiation is the s domain. If it is divided by t, it is the integration in the s domain. Right? xt by t, integral t say infinity xs, sorry, it is not t, it is s, it should be s, integral s to infinity xs ds. Integral s to infinity xs ds, right? These are some important properties of the Laplace transforms to be put down. Okay, right. The important pairs also we have noted. Okay, some important points about relating the properties of Laplace transform with the causality of system, right? So you all know that for the system to be causal, impulse response is right-sided. Impulse response ht should be 0 for t less than 0. That is the condition of a causal system. That is the condition of causal system, right? That means the impulse response is right-sided. Now, if any signal is right-sided, its ROC is also right-sided. Now, what is the Laplace? ROC is for Laplace transform. What is the Laplace transform of ht? ht has the Laplace transform hs. We know that ht is known as impulse response and hs is known as the transfer function of the system. So it has the Laplace transform hs which is known as the transfer function, okay. So if the signal is right-sided, ROC of hs will also be right-sided. That is why we say that ROC associated with the transfer function of a causal system is also right-sided. So if a system is causal, the ROC of the transfer function should be right-sided. It is related with the property of ROC only, nothing new here. Similarly, if a system is stable. Now, what is the condition for stability in the time domain? The stability implies that the signal should be absolutely integrable. Integral mod ht dt should be less than infinity. The signal is absolutely absolutely integrable. Okay. And if a signal is integrable. Dirichlet's condition भी यही होता है ना. In the last class we were revising the Fourier transform properties also. Absolutely integrable is also related with the Dirichlet's condition of the existence of Fourier transform. Dirichlet's condition for existence of Fourier transform, and in such a case ROC must include the j omega axis. In such a case ROC must include the j omega axis, because just now I told you na, for a Fourier transform to exist, now signal is absolutely integrable, then only the system is stable. If the signal is absolutely integrable, it satisfies the Dirichlet's condition. If it satisfies the Dirichlet's condition, Fourier transform exists, right? And for the Fourier transform to exist, ROC should contain the j omega axis. So that is what is linked. So what is the stability condition with ROC? ROC should include the j omega axis. Very important condition: location of poles for a stable and causal system. For the system to be both stable and causal. For the system to be both stable and causal. A system is combining the previous two property. This is the result we obtain. A system is both stable and causal if and only if all the poles of the transfer function lie in the left half of the S-plane. All the poles in LHP. Okay. Then only the system is both causal and stable. Okay. Then only the system is both causal and stable. Right. Chalo. Moving ahead to the next. Let us also, link some of the properties of the Z transform here. Okay. First its definition and then its property. Okay. So Z transform of a discrete time signal xn is given by the formula, as you know, summation of xn z power minus n, and we call this Z transform xz as a function of z, and we again represent this as a double-sided arrow representing a Z transform pair. Xn having the Z transform xz, xn having the Z transform xz, and reverse, vice versa, xz is having the inverse Z transform of the xn. Inverse Z transform of the xn. The xn has the Z transform xz and xz has the inverse Z transform of the xn. Okay. Right. That is what is the Z transform basic case. Z is again a complex variable, as you all know, and Z is written as R e power j omega. R is known as the magnitude, and we write down R is the magnitude of Z, that is mod of Z, and omega is the argument, that is the face of the complex number. Like ROC, every Laplace transform has ROC, similarly every Z transform will have ROC. Sir, why? Okay. Let us say why. DTFT पे बात पे आते हैं. Okay, because after some time we are going to revise the DTFT formula also. Chalo, let me just brief you here, and then we will come to the DTFT formula after revising this formula. So what is the DTFT formula in general? DTFT is nothing but the Z transform evaluated on the unit circle. Like Fourier transform was the Laplace transform evaluated on the imaginary axis. Okay, DTFT is equal to the Z transform evaluated over the unit circle. Right, over the unit circle. This is what is known as the unit circle. What is unit circle? What is the equation of any circle in the Z plane? Mod Z equal to A is a circle with the center at 0, 0 and the radius equal to A. So mod Z equal to 1 is the unit circle. Center is 0, 0 but the radius is equal to the 1. Good evening, Nitya. Radius is equal to 1. Okay. So when you put Z equal to e power j omega in the previous formula, e power j omega, so ये कितना हो जाएगा? Okay, e power j omega, z raised to the power minus n. So power multiplied, you get e power minus j omega n, and summation of x n e power minus j omega n. Summation of x n e power minus j omega n is known as the DTFT. So we have a clear connection between the DTFT and the Z transform. DTFT is the Z transform evaluated on the unit circle. See, Ravi, DTFT earlier was not there for the EE syllabus, but now it is there because from 2021 they have mentioned Fourier analysis of discrete time signal. Fourier analysis means it's include the DTFT, DTFS, everything that is included there. Okay, so I don't say much important, but at least that filter based analysis, identifying low pass, high pass filters. Okay, so not much important, but yeah, you must prepare it. Z transform is very, for electrical, Z transform, and number 2, continuous time Fourier transform. These two are very important from the signal and system for the electrical point of view, right? Great. Chalo. Okay, yeah, we can include them. Anyways, we'll just revise the formula only, Nitya. If you want a separate session, we can plan a separate session also. That's also a nice idea, and just taking up sometimes students, whether they know the initial or final value theorem or not, we can take a separate session also, initial and final value theorems pe. Okay, combining both discrete and continuous. Okay, now guys, this is the relation between the DTFT and Z transform. Okay, once again, let's take an example. If I consider Xn, one case, let me explain you so that it is easy to put down the formulas of other. If Xn is a power n un, what is its Z transform? What is the Z transform? So as we know, Z transform is given by the formula summation minus infinity to infinity xn z power minus n, xn z power minus n. But once again, because of the un, the limit should be 0 to infinity, because un will only exist from 0 to infinity, right? EMFT part 2 is done, Mr. Beast. Monday, EMFT part 2 is done on the Monday. Okay, the summation 0 to infinity a power n z power minus n, that is a z inverse whole power n. That is a z inverse whole power minus n. Now, when I open this, this is actually going to come up as a summation series. Open for all values of n. So this becomes something power 0. Anything power 0 is 1. Okay, so you have 1. Then you have a z inverse. Then you have a z inverse ka whole square. Then you will have the a z inverse whole cube, and etc 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 up to infinite number of terms, and that is what makes an infinite GP. This is what makes an infinite GP. And what is the formula for infinite GP? First term divided by 1 minus r. First term is divided by 1 minus common ratio, but this will only converge. There is a condition. This will only converge if the modulus of r, the modulus of the common ratio is less than 1. Modulus of the common ratio is less than 1, right? So modulus of a z inverse is less than 1. That means modulus of a by z is less than 1, or I can say modulus of z is greater than the modulus of a. The modulus of z should be greater than the modulus of a. Modulus of z should be greater than the modulus of a. Correct? Mod z should be greater than mod a. Mod z should be greater than mod a. So mod z, see, as I already told you, mod z equal to constant, mod z equal to mod a. This represents a circle. This represents a circle with the center at 0 0 and the radius equal to a, radius equal to modulus of a. Now I want mod z greater than mod a. Matlab I want the region outside this circle. I want a region outside this circle. And once again, what is this known as? For me, this is the region in the z plane. This is the region in the z plane for which the z transform will exist. There is a region in the z plane for which the z transform will exist. How do I write down this z transform pair? I write down a raised to the power n un having the z transform. See, the answer was 1 upon 1 minus a z inverse. 1 upon 1 minus a z inverse. In the positive power also you can write, this is written as z upon z minus a, but mod z greater than mod a. So that mod z greater than mod a is the region exterior of a circle, and this is the region where z transform will exist, and we call this as region of convergence. We call this as the region of convergence, ROC once again. So like the Laplace transform, every z transform also has the ROC. Now with this intent, let us move and go and just watch out important z transform pair. But once again, before we watch the z transform pair, let us do one more thing. Let us first of all again revise the properties of the ROC. Okay, let us first come to this slide, because as I told you, like the Laplace transform ROC property, this is going to be the most important thing in this chapter. If something is most important, this is what it is. Properties of ROC. Like Laplace transform will have some similar properties like properties of ROC, and this is remembered. You don't need to remember the ROC of individual signal. You can deduce by logic. You don't need to remember the ROC with every Z transform property. If you remember this slide, many conceptual questions can be solved if you just remember these points, right? Yes, just allow me 2 minutes. Go through these points. It is somewhere similar like Laplace transform. Allow me just 2 minutes and I'll continue my discussions. Just allow me 2 minutes. Okay, yeah, let's continue. Let's move ahead. So, so once again, if I want to brief you these properties, like the Laplace transform ROC property, the only thing in Laplace transform, you had the regions parallel to y-axis. Here you will have the regions in the form of circle, but all those circles will be centered about the origin. Okay, like you have seen the case mod z greater than mod a. There was a circle, radius a, and centered about the origin. So ROC was outside this, or it may be inside this depending on signal, but it will be always in the form of, circular regions centered about the origin. Again, ROC cannot contain any poles, that is pretty obvious. And if a signal is of finite duration, right, finite duration, ROC is again the entire Z plane, except here maybe sometimes there can be a pole at 0 or infinity. You have to exclude that, except possibly Z equal to 0 or infinity. That is why I'm telling possibly, not always sure. See, what is the meaning of this? एक example से समझिए, right? For example, delta n. I will tell you all the formulas also for the important Z transform pair, but just look into this directly. Delta n is having the Z transform 1, right? ROC is all Z, entire Z plane, right? But when I talk about delta n minus 1, what should be the Z transform? 1 into Z inverse by the time shift property. 1 into Z inverse, or you can calculate direct also by the Z transform formula. So 1 into Z inverse, this is like 1 by Z, and there is a pole at Z equal to 0. 1 upon Z creates a pole at Z equal to 0. So now this is also a finite duration signal. This is only one point signal, right? There's only one sample, but still the ROC will not be the entire Z plane. It will be entire Z plane, but except one point, that is Z equal to 0, right? So I can say that ROC is mod Z greater than 0. Only Z equal to 0 is to be included, right? Or I can say something like this. ROC is entire Z plane. No problem. ROC is the entire Z plane except Z equal to 0. 0 nahi aana chahiye because that is a pole. ROC cannot contain any poles. That is the logic you can mix here, right? So for finite duration signal, ROC is entire Z plane except 0 or infinity. That is also not sure. Okay. But you can deduce once you know the signal. If there is a pole at 0 or infinity, you have to remove those points, otherwise not. If a signal is right-sided, then ROC is the region in Z plane outside the outermost pole, right? That means it's like exterior circle. Let me write down in short. ROC is the form of exterior circle. And where is the exterior circle? Exterior circle outside the outermost pole. Okay. If the signal is left-sided, then the ROC will be interior circle, right? Interior of a circle lying inside the innermost pole. If the signal is two-sided, then ROC will, like the Laplace transform ROC was a strip, here it will be a region between two circles. I told you ROC in Z plane is always like a circle. So a region between two circles. ROC will consist of ring in the Z plane. ROC will consist of ring in the Z plane. Okay, a portion, something of this kind. Will contain a ring in the Z plane, a portion between two circles. And already we have discussed what is the condition of DTFT. DTFT is the Z transform evaluated on unit circle. Z transform evaluated on unit circle. But now we have learned every Z transform has ROC. So that ROC should contain unit circle, because if the ROC does not contain unit circle, Z transform is not defined. Okay, so DTFT will also be not defined at that point. So for the DTFT to exist, ROC should convert the unit circle, should include the unit circle. Oh, that is what is the last point relating the ROC of the Z transform with the DTFT. Already the direct formula relation between DTFT and Z transform I have covered for you. Okay, this is what is important. Now, once again, let me go back and first of all, let us see the important Z transform pair. As I told you, questions can be sometimes on these formula. That will be simple 1 marker. But most commonly, they pick up one of these formula and they include this with some property, and then they make a good 2 marker question. So again, as a GATE aspirant, you must remember these pairs. Every time you cannot go and derive what is the Z transform of a power n, un, ya a power n, u minus n minus 1, etc. Okay, so guys, let's quickly have a go through of these Z transform properties. Delta n, as I already told you, is having the Z transform 1. Every transform of impulse will be always 1. ROC is entire Z plane. A power n un 1 upon 1 minus AZ inverse or Z upon Z minus A. Negative or positive power formula both. Right sided. Now guys, already we have derived the ROC mod Z greater than mod A. But how do you remember it logically? What does the logic says? लॉजिक ऐसा बोलेगा, देखो लॉजिक सेज फर्स्ट कैलकुलेट द पोल इज z इक्वल टू a and the type of the signal is un means right sided. So if a signal is right sided, ROC will be circle outside the pole a, या outside the pole mod a may be positive, negative, radius can never be negative na, तो mod z greater than mod a, finish. So that means even if I don't remember this, I am okay, I know the logic. If a signal is right-sided, ROC is exterior of a circle lying outside the outermost pole. What is the outermost pole? There is only one pole. That itself is the outermost pole, largest pole. Okay. A power n u minus n minus 1. Sorry, this is u minus n minus 1. There is no role of t here. Will have the Z transform. Minus 1 upon 1 minus AZ inverse या minus Z upon Z minus A. Once again देखो, pole is Z equal to A. Signal is u minus n minus 1. Left sided है. So ROC should be interior of circle. Inside what? Inside the pole A. Yeah, magnitude of the pole mod A. So mod Z less than mod A. Remembered? Logically. याद नहीं रखना है. Only logic to be applied. Okay. Next one. Okay. A power mod n. Two-sided signal. This one is two-sided signal. Okay. So ROC. See, if you look at the poles, Z equal to A and Z equal to 1 by A will be the pole. So ROC is the region confined between the two poles. Mod A less than mod Z less than mod 1 by A, provided mod A should be less than 1. Because what will happen if the mod A is greater than 1? Right? If the mod A is greater than 1, you will never get a common ROC here. Okay. There was a question in gate once. याद आ रहा है इसलिए बता रहा हूँ. There was a question in gate once. Gate में पूछा क्या question था? What is the ROC of 2 raised to the power n un? Oh, sorry. The question was ROC of 2 power mod n. The ROC question of Z transforms is very common in the gate exam. Just the ROC. What is the ROC of 2 power mod n? So देखो, this is the 2 power mod n where A is equal to 2 and modulus of A. Right, this is the A power mod n case where A is equal to 2, right, and mod A is greater than 1, so there is going to be no ROC. Right. For the ROC of 2A power mod n to exist, mod A should be less than 1. We are not deriving here. If we go for derivation, we can do it simply, but let's stick to the formulas. Okay. A power n un, sorry, this is n A power n un, again there's a typo error. A power n un तो already told, n A power n un will have the Z transform AZ inverse upon 1 minus AZ inverse whole square या AZ upon Z minus A whole square. Again the pole is at Z equal to A, so ROC should be mod Z greater than mod A because it's a right sided signal, right? UN, unit step signal, coming to the important one step, will have the Z transform Z upon Z minus 1 या 1 upon 1 minus Z inverse. ROC, you only decide. Pole is Z equal to 1. Signal is UN, the right sided, so ROC should be greater than 1. Simple. Okay, NUN, this is the ramp case, unit ramp signal in the discrete time domain. Okay, so Z upon Z minus 1 whole square, ROC mod Z greater than 1. Sinusoids, cos omega and UN, sin omega and UN. So cos omega and UN, Z upon Z minus cos omega upon Z square minus 2Z. यहाँ पे भी Z missing है. 2Z cos omega plus 1. For sin omega and UN, Z sin omega upon Z square minus 2Z cos omega plus 1. ROC mod Z greater than 1. Okay, now these are the important Z transform which you must remember. I again repeat, impulse, right sided A power n un, left sided A power n u minus n minus 1, right sided and left sided exponentials. Okay, two sided exponential signal, n A power n un. This is derived using the Z differentiation property. I am going to brief you that. Step signal, ramp signal and sinusoids. And sinusoids are also not much important in Z transform in the discrete domain, but yeah, I have written it. So these are some formulas you must remember. Any question other than that will be solved using the properties. So now what are the important Z transform properties? Again, linearity is again very common. If two signals are added, Z transforms are added. Now Z transforms are added matlab two different, sorry, this is not LT, this is ZT. Sorry, this is the Z transform. I think that is copied from there. This is the Z transform. This is the Z transform. Okay. Once again, I tell you that if two Z transforms are coming together, every Z transform will have ROC, and you have to satisfy both their ROC. You have to satisfy what? You have to satisfy both the ROC, right? For x1 Z to exist, you have to satisfy R1. For x2 Z to exist, you have to satisfy R2. Matlab you have to satisfy their intersection. You have to take the ROC which is common to both. You have to take the ROC which is common to both. So R1 intersection R2. It is the R1 intersection R2, right? Time shifting producing the Z power minus n naught term. That is what itself is the exponential term here. The x of n minus n naught, Z power minus n naught xz. Sir, what is this? बिल्कुल याद ही नहीं रखना है. I have written this as a formality for the completion of your notes, but if you remember the ROC properties, important notes about ROC, nothing to be remembered from here. Just remember one point ki whenever two Z transforms are together, the ROC should be taken as the intersection. Okay, so that both are satisfied. No need to remember. Okay, just remember up to this point. Fine. Just remember up to this point. That's it. Okay, now Z0 power n xn, scaling in the Z domain, Z0 power n xn will have the Z transform x of Z by Z0. Okay, time reversal, x of minus n will have the Z transform x of 1 by Z. Okay, conjugation, x conjugate n will have the Z transform x conjugate Z conjugate. Time difference, this is just a continuation of time shift, nothing much. xn minus x minus n, xz, and this will have Z inverse xz. xz ko common le liya, so you have xz into 1 minus Z inverse. Okay, accumulation, okay, summation k equal to minus infinity to n xk. This is x of k. Summation minus infinity to n xk. Summation the xz divided by 1 minus Z inverse. This is like, now what is the ROC? Jahan samjhana hai wahan bolunga, rest it is by logic, so I am not considering about these ROC. xz into 1 upon 1 minus Z inverse. Isko aisa likh sakte hain. This is like xz upon 1 minus 1 upon 1 minus Z inverse. Now this is like 2 Z transform. What are the 2 Z transform? One is xz, and this is the Z transform of the unit step signal. I'll show you now. This is the Z transform of the unit step signal. Have a look into this. 1 upon 1 minus Z inverse is the unit transform of the, is the Z transform of the unit step signal. What was the ROC? Mod Z greater than 1. That means 2 Z transforms are coming, and I already told you, whenever 2 Z transforms are coming, ROC has to be intersection of both. What is the ROC of xz? Suppose that is R. What is the ROC of unit step? Mod Z greater than 1. So I have written the intersection. Clear na? I have written their intersection. So that is the logic behind this ROC. Convolution. Convolution in time is always multiplication in the transform domain. So xn convolution yn is xz into yz. Right. ROC is R1 intersection R2. R1 intersection R2. Right. nxn, Z differentiation property, right, will have the Z transform minus Z d by dz of the xz. Minus Z d by dz of the xz. These are the important Z transform properties, important Z transform pair. Why this went there? Sorry. This is already discussed. This was very important. Again, I repeat, if you remember this, many of the good problems of Z transform and many of the properties that you remember with respect to Z transform ROC property, no need. Z transform property ka ROC kya hoga? Like, what is this ROC? No need to remember that. Okay, if you remember this particular slide, and this will help you in some good conceptual questions also. Good conceptual questions also. Okay. Right. Chalo. Let me add on one more thing here. Like we added for the Laplace transform. Okay, what about the causality? For the system to be causal, Hn should be 0 for n less than 0. That means Hn is right-sided. That means Hn is right-sided, right? Okay, Hn has the Z transform Hz. Hn is having the Z transform Hz, where Hn is known as the impulse response. Hz is known as the transfer function. So if Hn is right-sided, what should be the ROC of the Z transform? What should be the ROC of the Z transform? So ROC of the Z transform Hz must be in the form of right-sided signal का कैसा होता है? Must be exterior of a circle. This must be exterior of a circle lying outside, same property, right-sided signal property I'm just copying, lying outside the outermost pole. Lying outside the outermost pole. Lying outside the outermost pole. Okay. Right. If I want to include stability, what about a stable system? If I want to include the stability, what about the stable system? For the system to be stable, summation mod Hn should be less than infinity. Right. That means Hn is equal to absolutely summable. The impulse response of the signal must be absolutely summable, then only the system is stable. And if the impulse response is absolutely summable, it is like the Dirichlet's condition of DTFT existence. So I can say that DTFT of the signal also exists. Correct, na? I can say that the DTFT of the signal will exist. And what is the condition for the DTFT existence? Just now we have seen. Yes, ROC including the unit circle. Right. So I can say that ROC of what? Of the Z transform Hz. ROC of the transfer function Sz. Okay. Should include what? Sorry. Should include unit circle. This should include what? This should include the unit circle. This should include what? This should include the unit circle, everybody. This should include the unit circle, right? For the system to be both stable and causal, for the system to be both stable and causal, what is the condition? Combining these two, we get the condition that all poles of the transfer function Hz, like we saw in the Laplace transform, all poles should be in the left half plane. Here, all poles of Hz must lie where? Here, everything is compared with respect to unit circle. Na? All poles of Hz must lie within unit circle. That is, all the poles will satisfy mod Z less than 1. Mod Z equal to 1 is unit circle. So, all the poles should have magnitude less than 1. All the poles should have magnitude less than 1. So mod Z less than 1. All poles must lie within the unit circles. Magnitude of all the poles must be less than 1. That is what I can say. Okay. Now once again repetition of this slide. Let us continue from this. Already I have explained you some time back only that DTFT is the Fourier transform evaluated on the unit circle. Right. So DTFT converges if the ROC of XZ contains the unit circle. Yahan se begin karte hain. This is what we already know. I have discussed this already 2 times today. The DTFT will exist if the ROC of XZ converges the unit circle, and DTFT is equal to Z transform on the unit circle. What is unit circle? Mod Z equal to 1. Mod Z means the R equal to 1. So Z becomes how much? E power j omega. Z is R e power j omega. R ka value 1 rakha. So in the Z transform, you have Z power minus n. Right. Put down the Z equal to e power j omega. Then take power minus n. So you get e power minus j omega in term. Summation xn e power minus j omega n is known as the DTFT. This is known as what? This is known as the DTFT. This is known as the DTFT, right? So if the DTFT, for the DTFT to exist, ROC of XZ should contain the unit circle, right? Okay. So DTFT is always a periodic signal. That means x of omega plus 2 pi is equal to the x omega. Okay. Right. पहले मैं एक बार DTFT का this is the formula already written. The DTFT summation xn e power minus j omega n from minus infinity to the infinity, right? And you know, even if you try x omega plus 2 pi, e power j 2 pi is 1. Because of that, when you try x of omega plus 2 pi, you will get x omega. So DTFT is always a periodic function with period 2 pi, and it is a continuous function of frequency. Although you are calculating the DTFT for the discrete time signal, right? You have a discrete time signal xn whose DTFT is x omega. Again, we represent this in the form of pair, xn having the DTFT x omega having the inverse Fourier transform xn I DTFT. Okay, xn is a discrete time signal, but its DTFT x omega is the continuous function of frequency. That is why, we go for the concept of DFT. DFT is again the Fourier transform of discrete time signal, but where the frequency is also discrete. We discretize the DTFT and we get the DFT, that is discrete Fourier transform. Okay, so right now DTFT की बात कर रहे हैं, तो x of omega plus 2 pi is equal to the x of omega. That is always valid, and this is also important point to be noted about DTFT. Right, as I am telling you, xn is known as the IDTFT of x omega. So what is the IDTFT formula? IDTFT is given by 1 upon 2 pi integral x omega e power j omega n d omega. Right. Already Dirichlet's condition I summarized some moments back only. Dirichlet's condition for the existence of DTFT. The DTFT will exist if the signal is absolutely summable. Okay. The DTFT of a signal will exist if the signal is absolutely summable. That is, summation mod xn should be less than infinity. Right. Now again, as always, we have done for the other pairs also, other transform also. Let us take the important DTFT pairs. Okay, of the very common signals. Now these are those signals whose DTFTs must be, remember, you should not every time derive it. Okay, so let us recall these pairs and let us recall the DTFT important properties also. Delta n, again delta n hai to 1 hi hoga. Every transform results to 1 for the impulse signal, right? Okay, if the signal is 1, then the DTFT will be 2 pi del omega, like the Fourier transform CTFT formulas. E power j omega naught n will have the DTFT 2 pi del omega minus omega naught. Cos omega naught n will have the DTFT pi del omega minus omega naught plus del omega plus omega naught, like the CTFT regular result. Okay, the sinusoidal signal cos omega naught n will have the Fourier transform consisting of 2 impulses, only 2 impulses. Those impulses are located at where? Del omega minus omega naught, that is located at omega naught, and del omega plus omega naught is located at minus omega naught. So we have 2 impulses located at the fundamental frequencies of the signal. Okay, located at plus minus omega naught. Right. Similarly, you have for sine omega naught n, a power n un, a power n un. Now see how you can remember for a power n un. Okay, for these cases you can also remember from the Z transform formula also. Say for example, a power n un. What is the Z transform pair? 1 upon 1 minus a z inverse. Yeah, z upon z minus a, but with the condition mod z greater than mod a. Right. So a power n un, what should be the DTFT pair of this? So put down z equal to e power j omega, na? Put down, what is DTFT? It is the Z transform calculated at z equal to e power j omega. So everybody put down z equal to e power j omega, you get 1 upon 1 minus a e power j omega inverse to e power minus j omega, finished. Okay, but mod z should be greater than mod a, and for the DTFT, that ROC should include the unit circle. ROC should include the unit circle. अब देखो ROC क्या है? Mod z greater than mod a, right? For the DTFT, ROC we know that should include what? Unit circle. Unit circle is mod z greater than 1. This is only possible if mod a is less than 1. Suppose a का value 2 लिया आपने, right? Suppose if you take a equal to 2, so what will be the ROC? Mod z greater than 2. Mod z greater than 2, na? Now can it include unit circle? 2 is greater than 1, na? So if mod z is greater than 2, it cannot include, sorry, it should include mod z equal to 1, I'm sorry. It should include mod z equal to 1. So just try to satisfy 1 here, na? This should include mod z equal to 1. So 1 should be greater than mod a. That should be very simple. 1 should be greater than mod a. So what about mod a? It should be less than 1. What about the mod a? It should be less than 1. That is why this condition is coming up. Otherwise, I have shown you an example. If a is equal to 2, mod z greater than 2, and then if it is greater than 2, it cannot be 1. It cannot be 1. Right. So ROC includes the unit circle, and that is why we have the condition mod a should be less than 1. I have noted there. Correct. So now, यहाँ पे, suppose, let's stop and discuss a question here. Suppose, for example, I ask you 1 by 2 power n un, sir. What is the Z transform? What is the Z transform? 1 upon 1 minus a z inverse, 1 upon 1 minus half z inverse, mod z greater than half, mod z greater than mod a. But if I ask you a question, half power n un, tell me the DTFT. Right, so that is 1 upon 1 minus, what is the formula? 1 upon 1 minus a e power minus j omega. 1 upon 1 minus half e power minus j omega, because I know a is equal to 1 by 2 and mod a is less than 1. A is 1 by 2, mod a less than 1 is satisfied. So I can use the formula. Right. Now let me give you a question. Find the Z transform for 3 power n un. For the 3 power n un, what should be the Z transform? Z transform लिखते हैं सबसे पहले. So for 3 power n un, it is 1 upon 1 minus a z inverse. Z transform will exist, but that will have some ROC. ROC mod z greater than 3. ROC is mod z greater than 3. Again, you can get an idea. Mod z greater than 3. So it cannot be 1. And if mod z cannot be 1, DTFT cannot be there. So if I ask you the question, 3 power n un, what should be the DTFT? Its DTFT does not exist. 3 power n un, sir, what should be the DTFT? Its DTFT does not exist. This DTFT does not exist. Now, you can say from two different points. Mod z greater than 3, so it cannot be 1. You can relate with the Z transform. Or you can relate with the formula I told you. Mod a should be less than 1. So, here to a 3 hai, that is greater than 1. DTFT will not exist. Okay. That is why these formulas are rare. Right. So, this is just an option to you. A power n un, either remember the DTFT formula or you can deduce from the Z transform as well. You can deduce from the Z transform. Right. Okay. Similarly, for a power n u minus n minus 1. Similarly, for n a power n un, all these are related with the Z transforms directly. Okay. Next one, unit step signal. यहाँ पे आ जाते हैं. For the step signal un, the DTFT is given by 1 upon j omega plus pi del omega. 1 upon j omega plus pi del omega. Rect n by 2n. Okay, rectangle having the total width of 2n. Okay, that is, this signal is equal to 1 minus n less than equal to n less than equal to capital N. So the total duration will be 2n minus n to plus n. Total number of samples will actually become 2n plus 1. So rect of n by 2n is a rectangle from minus n to n, and its DTFT is given by the formula sin n plus half omega upon sin omega by 2. Sampling an, sampling function, rect in the time domain, sampling in the time domain, sampling an will have the DTFT. This is same as the CTFT formula. This one is different, but this is same as the DTFT. Pi by a rect omega by 2a. Ideal low pass filter case, right? I explained you this in the last class. Ideal low pass filter case. Right. Ideal low pass filter case with the cutoff frequency of a. With the cutoff frequency of a. Same as I explained in last class. You can just go and note that. Okay. Important DTFT properties. The important DTFT properties. Once again, if two signals are added, the DTFTs are also added. There's nothing great here. If two signals are added, DTFTs are added. A1 x1n plus A2 x2n will have the A1 x1 omega plus A2 x2 omega. Time shift, exponential term, phase term in the frequency domain. Shifting in time domain will produce an exponential term in phase domain. Shifting in the frequency domain will produce a phase term or exponential term in the time domain. Okay, x of n minus n naught e power minus j omega n naught x omega. Right, x of omega minus omega naught e power plus j omega naught. Always in the frequency shift, the signs are reversed. Omega minus omega naught, it is e power plus j omega naught n. Okay, half period shift, minus 1 power n xn will have the DTFT x of omega plus minus pi. Minus 1 power n will have the DTFT x of omega plus minus pi. That is known as the half period shift. Okay, it's just simple. Okay, why half period? I told you DTFT is always periodic with period 2 pi. So pi is known as the half period. When you shift by half period, यहाँ पे omega को pi रखो, right? You get e power j pi n. The value of e power j pi n, e power j pi is minus 1. By the Euler's formula, you can say e power j pi is minus 1. So minus 1 power n. So this is the half period shift property, right? Time reversal, frequency reversal. X minus n has the DTFT x minus omega. Conjugation in time, the DTFT is x conjugate minus omega. And again, some important symmetry properties we can note from here. I will write down that separately. Time difference is continuation of time shift, xn minus x minus n minus 1. So this have what? This is having the DTFT x omega e power minus j omega n naught का value 1 है. Time shift corresponds to phase term. Take the x omega common from here, you get the formula. Accumulation, summation of xk from minus infinity to n, x omega upon 1 minus e power minus j omega plus pi x0 del omega, like the CTFT integration property. Okay. Differentiation in frequency domain, or this is also known as the n times property. Like t times, here we have the n times, n into xn, will have the DTFT j d by d omega of x omega. Convolution, x1 convolution x2, again DTFTs are multiplied. Convolution in time, transforms are multiplied. Multiplication in time, duality के according, the Fourier transforms are convoluted. 1 upon 2 pi x1 omega convolution x2 omega, and just like the CTFT, we have the modulation once again. xn cos omega naught n, xn cos omega naught n will have the DTFT x omega minus omega naught plus x omega plus omega naught whole divided by the 2. If a signal is multiplied by cos omega naught n, if any signal xn is multiplied by cosine signal, its spectrum is shifted to higher frequencies. Its spectrum is shifted to higher frequencies and centered at plus minus omega naught, x omega minus omega naught plus of x omega plus omega naught and whole divided by 2. And whole divided by 2, right? Amplitude whole divided by 2. So that is what is the modulation theorem once again. That is what is the modulation theorem once again. Some more important results to note with respect to the DTFT, that is the Parseval's relation. That is the Parseval's relation. Okay, so the energy in the time domain, you know, it is the summation mod xn square. But again, if the summation, you know, it's complicated to calculate in the time domain, we use the Parseval's relation. It is 1 upon 2 pi integral mod x omega square d omega. Okay, where the integration is over one time period. Integral over 2 pi here represents that integration 0 se 2 pi, or it is integration minus pi to pi. Based on the signal, we take the call what is better for integration, what range is better for integration. But integral 2 pi in general represents integral over any one time period. Integral over any one time period. Okay, so like the area property, in the CTFT we revise the area property, here it is the sum of the series property. Okay, so x omega, we all know that x omega is summation of xn e raised to the power minus j omega n, right? Omega ko kiya 0, right? So e power 0 becomes 1, you get summation xn, right? At omega equal to 0. At omega equal to 0, right? So if you want to calculate sum of series, okay, it is equal to the Fourier transform. It is equal to the Fourier transform calculated at omega equal to 0, and that is why we call this point as low frequency gain also. Omega equal to 0 is the low frequency case. That is the low frequency gain or sum of series. Okay. Similarly, we have the high frequency gain. What is the high frequency? Omega equal to pi. See here, the DTFT x omega, the DTFT x omega is spread over a range of 2 pi, because after 2 pi it's a repetition. The DTFT is periodic in nature, it repeats after every 2 pi interval, right? So DTFT is one information of DTFT is in one time period where omega, I can say, belongs from minus pi to pi. Omega belongs from the minus pi to the pi. Okay, so what is the high frequency? Okay, low frequency is omega equal to 0. Pi here is known as the high frequency. The high frequency here is pi. In the continuous time domain, the high frequency is infinity. In the discrete domain, the high frequency is known as pi, and the gain at high frequency. So if I put omega equal to pi, right, e raised to the power minus j omega n will become e raised to the power minus j pi n. E power minus j pi n is e power minus j pi whole power n, and e power minus j pi cos pi minus 1 minus j sin pi to 0. That is why this becomes minus 1, right? So you know the DTFT formula, you have summation of xn e power minus j omega n becomes summation of xn minus 1 power n. That is the gain at high frequencies. That is what is known as the gain at high frequencies. High frequency in the DTFT is equal to pi. Just remember that, just make a note of that. Okay, gain at the high frequency is known as the pi, right? Acha. Also, just I am able to remember, so let us keep a simple password also for the session. Okay, the PDF will be shared in the Telegram. I have shared the signals part 1 PDF also. Okay, and the PDF of this particular session also will be shared in the Telegram, and the password is going to be frequency. Everything in small. The password for today's session will be frequency, and the PDF will be in the Telegram group. All those who are live, all those who will be watching the session later on also will get this password. Frequency. Will get this password that is known as the frequency. Right. Okay, first again a quick reminder from my side that on the BYJU'S Exam Prep app, okay, this is not on YouTube, okay, so you can download the app from the Google Play Store and register for this free mega workshop where we are going to talk about the detailed 1-year preparation strategy for GATE 24. Yes, if you are one of the GATE 24 aspirants, yeah, your juniors or colleagues may be willing to prepare for GATE 24, you can update about this workshop, which is coming live tomorrow. That is Saturday at 8 p.m. on the app. Do watch it live. Okay. Also guys, a quick reminder that Sunday, day after tomorrow at 11 a.m. we have this live quiz. So we have, taken several sessions of the general aptitude on our channel where we were talking about concepts and questions up to this point of time. This Sunday, let us test how actually our preparation is in aptitude, how well we are in aptitude through a live Menti quiz on the same channel. Do not forget to subscribe the channel in case you are not still subscribed. Okay. Quick. So guys, in this signal system formula revision, in the quick revision, we have covered up important formulas, important properties. Okay, maybe not 100%, but the most important areas like CTFT, CTFS, Laplace Transform, DFT, not DFT, the DTFT, Z Transform, all these at least we have covered. That makes a good formula book for you. Hope these two sessions, in this limited time span, I have 1 hour around for both the sessions. Okay, whatever are the most important topics I have covered you. Yeah, DFT again stands out to be a very important topic for EC candidates, and DFT I have already taken a marathon. That was last time. Again, I'm planning a separate marathon for the GATE 23 aspirants for important topics like DFTs and all those important topics which are very, very important, branch specific we will plan. Right, but in case still if you want to see the DFT marathon right now also, I have taken that last year. The DFT remains to be same, so you can watch that marathon also. DFT is an important topic, especially for EC. Chalo guys, okay, bye bye. Right, so in this limited 1 hour session, it's already 1 hour 20 minutes as of now for today. Okay, we have covered up the most important formulas in this particular bandwidth. Hope these sessions help you. Okay guys, for EC students, tomorrow at the same time 6 p.m. there will be the sessions of communication systems. Yes guys. Right, many of you were waiting for the communication system. So tomorrow on the same channel, Saket Verma sir is going to take the formula revision of communication. Right, and for electrical students, I have another important announcement. Very soon, Ashu Jhangra sir will be taking the formula revision of power electronics. Yes guys, so all ECEE channels, all ECEE faculties will now be combined, and even Saket sir, Ashu Jhangra sir, all of the faculty members will be taking the ECEE sessions on this particular BYJU'S Exam Prep YouTube channel. Do not forget to subscribe. So guys, tomorrow, Saturday and Sunday, 6 p.m. communication formula revision. Saturday and Sunday at 6 p.m. communication systems for EC. Communication formula revision will be there by Saket Verma sir. Right. Tomorrow and Sunday 6 p.m. join Saket sir for the communication formula revision. Bye bye, stay safe and take care of yourself.